So what we're doing is we are in our textbook, correct, guys? We're going to go to the questions that we need to answer. Please turn to page 36 in your textbook. So right now, first thing you did was you recorded, but you actually wrote down your notes for today, correct, everyone? Mm-hmm. And so now what we're doing is we're answering the questions on page 36. Everybody on page 36. So what I would like you to do in your ISM book, draw you a line where your one-pager stopped. And now what we're going to do is we're going to answer the questions that are in the textbook first. Everybody good so far? So first thing it says here, it says, how does a motion diagram represent an object's motion? Yep. So write this down. Motion diagrams show the position of the objects moving at equal time. So the answer for question 1 is a motion diagram shows how a position of moving objects at equal time. And remember what that means. When we're talking about this motion diagram, we're talking about the dots, right, guys? And remember how you saw on the page with the person that was walking by the tree, they actually had a dot. So what I would do if I was you, I would do this underneath here. That would show me that's what it looks like. Those of you who are at home, if you would please type in the comment your name, and that way I'll have that record. Number 2 says, motion diagram of a bike rider. Draw a particle model motion diagram for the bike rider moving at a constant pace along a straight line. So what do you think we need to have based on what Ms. Sloan has said so far? Okay, so how are we showing that he is driving down the street at a constant rate? Yep. So here is my dots, right, guys? When we talked about this in class, these arrows will kind of need to be the same size, right? Because if my arrows are not the same size, what does that mean he's doing? If they were smaller, what would it mean it was doing? On number 2. Yes, we are. Thank you very much. Questions so far? And you're going to have a little bit more practice with the handout in a minute. I wrote down each dot represents the position of the bike. So each dot represents the position of the bike. Also put on here that the elapsed time is equal spacing, rate is constant. So what I mean by that is the arrows are the same length. This is telling you he's going. What would we do to make sure that it shows that he stopped? How could we show that he stopped? Will that tell me it stopped? This is telling me if I was saying he started from a stop, right? If I wanted to include that, would it look like that? Yes. This would be my start position. This would be my end position. This shows me velocity and also show me that he's moving at a constant speed until he comes to a complete stop. Does everybody understand so far? We're all good. Okay. So now let's go to number 3, Xavier. So number 3 says, motion diagram of a car. Draw a particle model motion diagram corresponding to the motion diagram on figure 4. For a car coming to a stop at a stop sign, what point did it use to represent it? So what are we going to use to represent the car to start with? What is the car? The car is the object, right? Yeah. Okay. So what's going on with the car? Stopping at a stop sign. Did I kind of already show that over here already? Yeah. Yeah. So we can just do it this way if you want. Because that's what I did. I added it to show you that he stopped at a stop sign. What represents the car? The dot, right? The arrow represents what? The motion and direction, right? Are we good so far? Okay. Let's go look at number 4. Number 4 says, motion of a diagram of a bird. Draw a particle model motion diagram corresponding to the motion diagram in figure 5 for the flying bird. What point of the bird did you close to represent? What point on the bird did you choose to represent the bird? So, if we were drawing a bird, okay, what is this bird doing? He's flying kind of like at a thing, right? He's kind of flying like this, isn't he? Right? So if I was doing this, my motion map would look like that. Probably, and I'm going to show you, and God knows this is the best thing I can do. Here is my bird, okay? My bird is the picture itself, but what represents the bird is the dot, right? And then the vector, if you want to call it that, the arrow, is showing me direction and if they're speeding up or not. Is everybody good so far? I know your bird's going to look better than mine. Number 5. Number 5 says, draw a particle motion map diagramming 2 runners during a race in which the first crosses the finish line and the other is 3/4 of the way to the finish line. Okay? So, did they both start at the same place? Yes. Can I erase the top so you can see? This is going to look a little foreign to you, but it's okay. Okay? So if we had the first one and the second person, did they start at the same place? Okay? We're going to say this is 0. 1, 2, 3, 4, and 5. Okay? 5, I'm going to say is the finish line. What I would like you to do is take a moment, and I would like you to diagram it the best way you can. Now, you're going to have your runner 1 and your runner 2 is going to be here. They both start at the same place. But what happens to both the runners? Who finishes first? Draw a particle model motion diagram of 2 runners during a race. The first runner crosses the finish line, and the other runner is 3/4 of the way to the finish line. Okay? So, my little first person, he finishes the race, right? He's done, isn't he? Okay? Where's my second runner at? 3/4 of the way, right? So where is 3/4 of this number line? Where would it be? Is the runner at the very beginning going faster? Is the runner at the very beginning finish the race? Did the person at the second one, did he finish the race? Not yet, has it? Does that make sense to you? So I'm going to ask you, this means I completely understand. This means I'm not quite sure. And this means I don't understand at all. Where are you? Yay. Good. Awesome. So now what I'm going to do is I'm going to hand out a motion map handout. Okay? Now, this paper is called Four Corners. What do you think this paper is called Four Corners for? Because there are 4 on the page. Okay? Now, this packet we're going to do all week. So it's not a big deal. Okay? So don't think we have to do it all. And those of you who are online, if you give me a minute, I'm going to include yours. So here's the packet. So what I want you to do is I want you to take your paper and I want you to fold it. And I want you to fold it again. And you are going to start on this page right here. Okay? So what I want you to do is I want you to go ahead and start reading this page and seeing what it says. Those of you at home, if you'll just wait a few minutes, we're going to go over it and you'll be able to see it on the board. And then I will make sure this packet is on for you today as soon as I get done with this class. Okay? Okay. So let's look and see what it says here. It says a motion map represents a position, velocity, and acceleration of an object at various clock readings. It says, suppose that you took a picture of a car moving right at a constant velocity. This is a motion map representing the car. So in your notes, are you ready? What I would like you to do is I would like you to draw this motion map. Are you ready, guys? So you need to draw an X. You need to draw a line with an arrow. And then what I want to do is this says here, it says this motion map represents a car. We modeled the position of an object with a small point. At each position, the object's velocity represents the vector. So here, I have this. I have this. I have this. And I have this. Okay? Now, X is my starting point. It's telling us the car is traveling down the road in a positive position. What do you think would happen if he braked and went the opposite way? If he put his brakes on and went the opposite way. So right now, what this looks like is a car, or better yet, I'm walking at a constant velocity going in one direction. What would happen if I stopped and I went back the other way? How would I represent this on this motion map? So if I had stopped, right, guys? And I have to stop for a few minutes, right? So I'm going to say maybe 3 minutes. And then I would go back in this direction. So draw that in your ISM book. So basically what I've done is I'm walking this direction at a constant speed. I have stopped. I have turned around. and I have gone back this way at a constant speed. Does everybody understand? Constant acceleration, stopped, and then went back the other way. Does everybody understand? And then what I would do is on here, I need to have a start and an end. Is everybody good so far? If you look, it's showing the car again, but this time he has a greater velocity. So to be able to represent that, how would I show him having a bigger velocity on this one down here? Lots longer, right? So I have a dot here, a dot here, a dot here, right, guys? And my arrows are completely longer, aren't they? That means he's going faster, right? The next one says if the car is moving to the left at a constant velocity, and we've done that because he's going on the left there. And then now it's showing you a completed map. That's what I have here. The only thing that I'm different with compared to what was on the paper is they had an end here. Based on that, sorry, Crystal. Based on that, what happened? How could I illustrate that with me? I would go constantly in this direction right here, right? I would stop, I would turn, but am I going to make it all the way back to where I started? No, because I didn't go all the way back to where I started. Do you have any questions? Good. Okay. Take your paper, put it inside your ISM book. Take your textbook with you. You will need your computer. And what you're going to do is you're going to go to your lab station now. Those people that are in the lab station, the buzzer has rung. Everyone. Wipe your station down and go sit down. Yes, sir, you do. Now, those of you that are at home, I will put on line for you this 4 squares. So what you're going to have to do, and I'm going to show you this. So what you need to do is you will need to go to Google Classroom today, where you see assignment number 12. It's going to tell you you need to read the pages for assignment 12. Your pages that you read was page 34 to 36, and we took notes. Then what we did is we did the questions, which we did in a small group here. And then what the students are doing, if you open up this assignment, you're going to see a Nearpod. Now what you need to do is get off of here and go to the Nearpod, and you will need to do the motion map section. In your ISM book, you're going to have these questions along with your 1-pager, along with notes that you have taken from here. And then you will need to go through and make sure that you turn all that in today. And I think I put it on there by 3 o'clock. If you put your name in the comment section, it's going to go ahead and tell me that you're here. So you get attendance for today. But please try to go ahead and go do that. And then I will see you again tomorrow at 12 o'clock. Have a good day.